Well, good morning, everyone. Welcome to the Elevations Geospatial Summer Series. We've got our sponsors we want to thank, first of all, before we start. Our platinum sponsor is Nearmap. Gold sponsors will be Woolpert, the University of Wyoming Geospatial Information Science Center. And then we have Frontier Precision also as a gold sponsor. And our silver sponsor for this week of the conference is Integrated Land Services. I want to thank all of our presenters and our instructors also for attending. We're using the Zoom webinar format where all of our attendees will be on mute. These sessions are being recorded. You will be sent an email after the event with the links to the recordings. There is a question and answer option to ask questions of the presenters, and they'll address that when they start. There is also a chat feature which should be used for technical issues only and will only be visible to the presenters and the host. If the presenter opens up the session to attendee participation and you would like to speak, please raise your hands and you will be unmuted. So let's go ahead and begin. I'm going to switch things to all panelists. And let me introduce our first presenters this morning. From Nearmap, we have Carrie, Wiley, and Charles Staton, who's going to be speaking on empowering context, collaboration, and community with high-res aerial imagery and GIS. Charles, looks like you're up first. Or Carrie? I'll let you guys decide. But
I'll go ahead and take it from there.
thank you.
Yeah, thank you so much for the introduction and welcome everyone. Charles and I are very excited to be here and presenting and be a part of the event. So we'll be doing some screen shares, a couple of videos, but let me go ahead and do share my screen here. Start my PowerPoint deck here, and then I'll jump over to a map browser overview demo here. But today we're going to be talking about Nearmap aerial imagery and some of our other products, empowering context, collaboration, and community with high-res aerial imagery and GIS. We'll have a couple of customer testimonials about how they are getting the most value from Nearmap imagery and their subscription. And we'll also cover some of our newer products, our 3D and our AI as well. So a little bit about myself and my colleague, Charles Staton. My background is in GIS and civil engineering. I am the strategic account manager at Nearmap, representing the public sector. And that includes all the accounts in the Colorado region and West. I currently reside in San Diego and yeah, we'll be presenting here. And so Charles is one of our geospatial sales engineer rock stars. I've had the pleasure of working with him here at Nearmap for a couple of years. And I'll let him kind of give you a little bit of the rundown on his background when he's presenting. So for those of you that don't know, Nearmap is an aerial imagery company. We are headquartered out of Sydney, Australia, but we've been capturing here in the US since 2014. So going on 7 years, we have an archive of imagery available. We do the top-down vertical ortho imagery as well as oblique, panorama, and a rich stack of other geospatial content such as 3D and our AI attribute layers, which we will get into. We work with a lot of technology companies such as Esri, Autodesk, GeoCortex, and a lot of GIS and CAD software companies that are out there. So what makes us a little bit different than the traditional aerial providers is that we are current. So we're capturing up to 3 times per year in a standard coverage footprint across North America and Canada. All of our imagery is sub 3-inch resolution, meaning each pixel represents a 3 inches or better on the ground or ground sampling distance. We are a subscription-based service, so we stream all of our imagery and our products through the cloud, so we make it extremely easy to access. We also, as I mentioned before, have that rich catalog of historical imagery dating back to 2014. So our Nearmap customers get access to all of that imagery on demand. We also integrate very, very easily. That's part of that cloud base that I forgot to mention. We offer APIs, web map services, and we also offer an Esri marketplace item, which makes it very easy to consume our imagery in your third-party applications. And so our coverage, as I mentioned, we're proactively flying a standard coverage footprint. We cover over 70% of the US population with over 339,000 square miles captured every year. And so what I want to do now, I'm going to stop sharing for a second, and I am going to get out of PowerPoint and jump over to Map Browser. Oh, sorry.
No, you're good.
Let me get back over to Google, my web browser here. Okay, so I'll do a quick high level overview of our web-based application map browser and a few of our products before I pass the show over to Charlie here. So what you're seeing here is our map browser application. It's all web-based, so you can easily access our products through the web, through the cloud, as I had mentioned before. So what you're looking at here is our top-down vertical, sometimes referred to as ortho imagery in the industry. And what you see here is a capture from April 3rd, 2021. And this is of a, looks like a warehouse development. So if I right-click here, you're going to see that timestamp was April 3rd, about around 11 a.m. And you're going to get coordinates, you're going to get the address. And this is going to be at a 2.3-inch resolution, so very high resolution. And what I want to show here, since this is being developed, I want to show you our archive of imagery dating back to 2014. So what's great about this, I can do this time slider, and you can see just back in September of last year, there was nothing here at this site, so it's being completely developed. So having that access to the historical imagery is really great for change over time. You can use it to showcase projects. County assessors use it a lot for site inspection and to determine if there are unpermitted building or unpermitted property changes. You can also use it for site planning or just anything that has to do with remote inspection. We've seen a lot of that over the past year when people have been forced to work from home. Having access to up-to-date imagery has allowed people to continue to plan and design and move forward with their projects. Now, I want to mention that something that makes Nearmap unique is our fast turnaround on our imagery. So we have our own proprietary camera systems that we mount in fixed wing aircraft. We're able to do that QA/QC, publish that imagery to Map Browser within 30 days of capture. Most recently, I've been seeing that turnaround time in as little as 7 days. So you can expect that imagery to be accessible very quick after we capture it from the air. Now with vertical, we also have other products. I'm going to come over here to an area that has a little bit of maybe the urban core here in Denver, so we can look at the oblique. So what I'm going to do, I'm going to drop a pin here on this building. I'm going to go over to oblique view. So we're flying our second generation camera system to capture these obliques. These are the source tiles here. These are all measurable. You can access the obliques from all 4 orientations. So if you want to see around a project site, you're going to get access to those different orientations. These are all measurable as well. So if I zoom in here to this, give this a chance to load here. If I zoom into this building here and I want to get the height, I can come in here, use this tool, and this is going to be within 6 inches of accuracy. So very accurate for doing height estimation, area estimation. Along with our oblique product, we stitch those obliques together to create this panorama, which is a sweeping bird's eye view at a fixed 45-degree angle. Now, these are not measurable, but these are great for site inspection, and you can also view these from all 4 orientations. Now, what's great about the oblique imagery is that we are able to do photogrammetry to produce a wide range of 3D content, and I'll quickly show that. Jump over to 3D view, give that a chance to load. So we have a massive library of 3D content. It's all streaming on demand. So give these cesium tiles a chance to load here on this Zoom share. Now our 3D content's all measurable as well. So you can do height measurements, you can do area, you can drop a pin and determine height above sea level here. And that's going to give you the coordinates and the address as well. But what makes our 3D unique is that we allow our customers to come in and export an area of interest on demand. I'll quickly draw a bounding box here. You can also upload a GeoJSON, which you can convert KML to GeoJSON. But what I want to quickly show you here is that you can extract different vintages. So the most recent vintage for Denver, Colorado is September. You can choose the projection system that you work in, which is going to save you a step in transformation in your third-party application. And then these are the content types that you can export: the textured mesh, OBJ and FBX work in Autodesk, SLPK in the ArcGIS Pro, ArcGIS Online, and then cesium tiles is what you're seeing streamed through Map Browser, and then 3MX is going to be a Bentley format. We also have a point cloud. We have elevation data sets, including a DSM and a DEM, a digital elevation model, and we also have that true ortho. So when you come in here, you can select 4 content types at once, download to your local hard drive, and then you can import those into your visualization and GIS applications. So that is a very high overview of a map browser. And what I'm going to do now, since we have time, I'm going to stop sharing and pass it over to my colleague, Charles.
Awesome. Thank you so much, Carrie. That was really great and a comprehensive overview of our online web application and our different content types that we produce. I'm going to try to show a video here. So I'm going to change some audio settings real quick. And Carrie, if you could just give me a thumbs up or down if this video starts to play correctly.
I'm the 3D Web Experience Product Manager at Esri. We're focused on providing the best experience for 3D Web GIS. Esri, the demand for 3D GIS has been fueled by the demand for new data types to including photogrammetric integrated mesh. And Nearmap really gets users started quickly with a great visual experience that provides context to the data, and it works in workflows that they're already used to producing. It provides a very clean and easy transition from 2-dimensional GIS to 3D, and it really helps folks get started. Urban environments are constantly changing and quite a bit more frequently than what cities are able to understand and to record within their system of record. Data from Nearmap helps organizations collaborate in that they can get the most recent picture of what's happening, and that return on investment speaks to risk mitigation, to situational awareness, and ultimately being able to quickly provide a common operating picture for all of the organizations that are involved with a major project.
Okay, so I'm going to switch my audio back. So we do have some videos that are peppered throughout this presentation just to kind of give really good grasp of our customer testimonials and how our customers and partners are actually utilizing our content. So be on the lookout for a couple more of those. I'm going to be trying to add a little bit more throughout the presentation. All right. So this is a good testimonial from Lori Soul, that she's the GIS manager for the city of Sioux Falls. And she is utilizing both 2D and 3D data. And I believe around this situation, we are going over different sites in web scenes. So when Carrie was discussing that ArcGIS SLPK file type, this is what she is using inside of a local scene to go and monitor projects such as this bridge being built here and monitoring that construction. Because a lot of these projects can be over several long months at ends of the year, or even several years. So this is a really good capture of how we're being able to utilize that camera system that's on the belly of that fixed-winged aircraft, capturing images from different look angles so that we're able to recreate this reality mesh type product in a variety of formats that's all geo-referenced with a vertical datum as well. So everything is spatially accurate. So monitoring your assets, being able to utilize the measuring capabilities and geo-referencing of all of this content really comes in handy when communicating with the public, especially in a forum or a proposed change that is undergoing in any populated area. Another great use case is Esri's flagship program is ArcGIS Urban. So let's explore this scenario of Boston inside of ArcGIS Urban with Nearmap's 3D textured mesh providing context. So I'm just going to show a flood hazard analysis here showing a 21-inch sea level rise. And these are the characterizing what buildings would be heavily impacted. And this is valuable information when planning or executing emergency response situations. So Nearmap's 3D textured mesh provides a context for events such as this. It really drives home the power and information you're able to leverage in the ArcGIS urban environments and Nearmap's 3D data. Some other applications that we do have, some other derivative products Carrie was going through is our digital surface model. And maybe if you're in a workflow that requires less of a visualization standpoint and more of an analytical calculated one, using the 2D DS digital surface model in this GeoTIFF form is really agile to use in programs like ArcGIS Pro that I have here. It is just a single band raster that shows the elevation by pixel values so that we see everything on the Earth's surface actually has its own unique elevation value in relation to mean sea level. So here I can see the surfaces of these buildings and these trees back in the neighborhood here. With our latest product, using our AI, we're able to create a digital elevation model to really give you that bare Earth scenario. So now we are removing all of the features on top of the Earth's surface and giving you just as the ground, so that digital terrain. And this is really useful in site selection and also when creating new developments. And creating things like a contour map here. So you're able to leverage those tool sets inside of the Esri suite to really drill down and run these analytical processes on any type of our data. And the GeoTIFF is going to be a much better user-friendly version from a calculation standpoint. But for those nice visualizations, you'll still want to utilize that textured mesh. All right, we have another video here. Let's see.
My name is Wayne Alsta, and I work at the Valley Water District. I title is an information systems specialist. Digital transformation is making our jobs easier every day here. One issue we run into is outdated data on our historical assets. This can raise questions when we want to plan new upgrades. High resolution aerial imaging from Nearmap can help give us an edge. Really gives us the ability to understand how other variables such as road changes and road maintenance are impacting our current conditions. And they update their image 3 times per year. This really gives us confidence and seeing how recent the imaging is. And it helps us with our current state of assets, like our fire hydrants, our water mains, our reservoirs, even our valves in the middle of the street. And this gives us real precision to plan our projects around. We integrate Nearmap into our ArcGIS collector for our guys in the field, and Elements, our asset management software. This just enhances our field and management applications with comprehensive location intelligence. This allows us to bring our users their devices in the field and simplify the data collection process to make it very streamlined, saving us time and money.
Awesome. So really utilizing the frequent updates, the availability and access to all of this content, and the ability to make decisions right from your home workstation or through the use of an online field collection application. There's numerous pathways that you can leverage Nearmap data, and that's just one of them. So let's talk about our latest and greatest piece of technology here. So Nearmap has been working on artificial intelligence for about the past 3 years now. And what we've done is ran this deep learning algorithm on our nationwide data set of imagery, starting with our fall 2019 capture. And then we also have a spring 2020 capture. And our plan is to subsequently run this deep learning algorithm on all of our imagery moving forward, so that people can not only see the change visually represented in the imagery, but also utilize those metrics that our AI algorithm is picking up so that they can see the change for calculations as well. So this is an earlier generation of what we have. First generation, our AI was just a very standard package full of vector features, such as building footprints and solar panels and things like that. The next adventure that we went to really was our second generation artificial intelligence, and that was expressed as a single band raster with pixel values from 0 to 255, and that was indicative of Nearmap's confidence level. So the closer that pixel value was to 255, the more confident we were in labeling that feature. Since then, we have progressed to our latest generation 3 artificial intelligence, and I'm going to show you some examples of that in a little bit. Some features that we are extracting are surfaces. So you can think of all of the impervious surfaces, asphalt, concrete slab, driveways, lawn grass, things like that. Vegetation as well, so shrubs, bushes, and then trees over 6 feet as well. We're also getting raised parking structures as well as the building characteristics. So let's kind of dive in and see what we've got here. I'm going to change my screen. So I'm in Littleton right here, actually just outside of Denver. And what I've got is downloaded a sample stack. My team and I are going to create several geographies of these sample stacks around the US so that our customers, partners, and even prospects can kind of see what we're up to in different parts of the country. So if I zoom out here, I just kind of want to show the sample set that I do have, and I've matched it to the exact capture date of this imagery. So we'll scroll down and we can see the acquisition date of the imagery that I've got here was March 28th of last year. And I've made sure to pull the exact same dates from the AI attributes that we're looking at to make sure that the imagery is represented correctly. So you can kind of see some of the items in my legend that we have here. And we've got a nice symbology display to show everything that we're actually capturing on this building roof characteristic. So you can see our survey date, our confidence level, the area of the roof, the building height, and if it is 1, 2, or 3 stories as well. Now we're able to capture the number of stories because of that rotating camera system that I mentioned earlier. So we're capturing using our oblique and panorama imagery to measure the number of windows and then give the user the number of stories on the building as well. So not only the area, but also the peak height as well. For things like vegetation, this is going to be high vegetation or bushes and trees above 6 feet. So this is giving you the area of that, the area that is covered by those trees. You could also overlay something like the digital surface model on top of this to show the exact peak heights of these trees because they are referenced in that vertical datum. So you could have the digital surface model, our AI, as well as our imagery underneath. So there's a whole lot of layering going on depending on what information you're trying to gain. We're also capturing solar panels as well. So this is a big driver from the roofing industry, the solar industry. Having all of this constantly updated data after every single capture is going to allow people to take advantage of those metrics as well as visualize them within the imagery itself. So let's take a look at what's possible. I'm going to switch over. So what we've got here is an ArcGIS online web application. And I've got my 2D imagery over here on the left, complete with an AI data set, as well as a 3D representation of our building footprints on the right. Now, how this was done, it was extracted utilizing our AI. So since we know the story and peak height of the buildings, we created that using a normalized DSM, excuse me, and then attaching those values to the peak heights of these buildings and extruding the polygons to their appropriate height based on our AI data. So I can click on this building here and know the area of it from the roof, as well as the number of stories and the ground to peak height of the building. We've also got a little bit of a flood dynamic going on here, and this is a really good representation to show what buildings would be affected, and you can even discern what number of stories that would reach depending on the building height. So this is a great example of really what's possible utilizing Nearmap content inside of a powerful ArcGIS online system. Okay, let me go back. So AI is really our latest innovation here at Nearmap, and we're going to keep continuing to utilize our imagery to extract many more features. I believe we're up to almost 35 or 40 right now, but those will continue to change and evolve and increase the more that we capture. So really what we say is if you can discern what it is in the imagery, our machine learning algorithm probably can be trained to do the same thing. So we're creating this historical archive after every single flight, and it's going to be provided to all of our customers and partners that are utilizing data with respects to managing assets, keeping an inventory of their utility network, as well as creating a system of record moving forward. So there's a lot to be learned from this, pun intended. All right. I'm going to stop sharing and then kind of switch gears. Let me go ahead and kind of recap So we do have a diverse set of location content here. Carrie was kind enough to go through that map browser demo and show us all of the vertical imagery with our camera systems, as well as the measurable obliques that return that source tile in a 2.2-inch GSD fashion, as well as the panorama that is that stitched together uninterrupted pan and zoom pattern. That same camera system that produces our oblique and panorama content is responsible for creating our 3D as well as some of our AI derivative content as well. So we have a lot going on. Everything is created from photogrammetry, and we would be glad to answer anybody's questions that we have so far. So let me see what we've got in the chat. All right, let's see. Chat. Any questions right now? I know I have some other customer testimonial videos. One in the Q&A. All right. Okay, we have one question in the chat, Carrie. They ask, do you fly every year for your customers, and what is an estimate cost for counties, and are you being used in any county in Wyoming? Let me see, Wyoming, I believe, let me just check and see here. We are not capturing it. Well, we do have a one capture. We cover 93 miles in Cheyenne.
And to add to that as well, we do have a coverage map available at nearmap.com/coverage. There you can check our standard footprint for our vertical and as well as our oblique and 3D captures as well there. There's an embedded ArcGIS online web map. We also have the ability to expand coverage. We've done countywide coverage expansions. We've also done statewide expansions as well. And so we work with agencies to determine costs based on the area of interest. So we would just need a KML or a shapefile or some sort of boundary file. And then we work with you on cost to determine what time of year, how frequent that capture will happen. And so we frequently work with that, agencies for expansion.
Okay, do you offer a demo trial period specifically for 3D, oblique, and AI functionality? Let's see, I know we have a 3D viewer subscription.
Yeah, we do. We have offered trials and demos previously, and we are open to that. So if there's interest, please reach out. I'll put my contact information in the chat box here in a second. And then connect with me, and we'll determine your needs for your agency and get you set up with a trial and explore that further.
All right. Okay. Let's see, do I have? I was going to show those other two videos, Carrie.
Charlie,
Yep.
someone was kind enough to mention in the chat when you play those videos, before you share your screen, there's an option to share your computer audio with that
really?
video.
Okay.
I believe so.
Perfect. I'm going to download these. let's see. Share computer sound. There it is.
It's just not playing the video. Okay, there we go, Jordan.
There we go. Share computer sound. So I'm going to play this one. This is from a testimonial from Shane Burnham, the city of Carmel, Indiana.
I'm Shane Burnham, GIS analyst with City of Carmel. Keeping GIS data as accurate and up-to-date as possible is difficult when we only have access to one annual aerial capture. Limited updates can often lead to deficiencies when it comes to asset management, which in turn can affect interdepartmental budgets around our city. Nearmap has allowed us access to the most current GIS data sets that we can. With such recency in what we're seeing, we can gain a much more holistic view into city-owned assets that would have previously been ignored, discarded, or forgotten about, which is definitely a long-term cost-saving measure for us as a whole. Updated imagery also enables City of Carmel to capture utility revenue that would have been either delayed or lost as well. Nearmap has really helped us bridge that gap and enables us to keep pace with rapid growth throughout our city. Our subscription really makes it easy for us to work aerial imagery into interdepartmental budgets every year with cost effectiveness in mind. And with updates that occur multiple times per year, we no longer have to worry about whether or not what we're seeing is the most up-to-date imagery as possible. Not all of our employees have access to GIS software either. With Nearmap's web-based application, they can access that imagery anywhere at any time with an internet connection.
Great. Okay. I do have another video, but we won't, put everybody through a watch fest. So if anybody has any other questions, please feel free to pop them in the chat. Ask them if you want to ask anything about Nearmap, about the content, about other customers, how they're using it, or if you want to ask us about anything, feel free.
So it doesn't look like there's any more questions. And if there are following today or at any time in the future, please feel free to reach out to me. My email is carrie.wiley@nearmap.com, and we'll be happy to set up additional demos or trials and explore the conversation further. But Charlie and I think we'd like to thank everybody for your time today, and hope you all have a great conference.
Yep, absolutely.
Charles and Carrie, thank you so very much. Very, very enjoyable, very entertaining, very informative, and really appreciate not only the presentation, but Nearmap sponsorship also of the Elevations Geospatial Summer Series. So thank you very, very much for that. Appreciate it.
Absolutely, our pleasure.
And there is, let's see, did something come up? Thank you in the chat room. There's actually, you guys still have about 20 minutes on your time. Oh, just another thank you and a boy, all these thank yous and no questions.
All right.
I figure you guys must have covered it really, really well.
I think so. That's all we've got.
Well, thank you guys very much again.
Yep.
So
Absolutely.
now we've got about 20 minutes until our next presentation, which will be Karen Rogers from GISYO, excuse me. Why don't we go ahead and take a break, and I'll start things back up at 5 to 10. 10 to 10, we'll get Karen lined up and whatnot. Unless Carrie and Charles, if you have anything else you want to.
Nothing from my end.
No, I think we could all use 15 minutes back in our
Yes.
day.
Yeah, get
sometime.
some
To
more
prepare
coffee
for our
and
next meeting. Yeah,
other
Yeah.
things. Thank you guys so very much.
Thank you.
Appreciate it.
absolutely. Have a great day, everybody.
And you.
You too.
I'll give it just a few more minutes and then I'll go ahead and turn it over to you. Well, I think my computer's a little slow. It doesn't quite say it's 10 o'clock yet, but my wristwatch, oh, now my computer is agreeing. Okay, well, everybody welcome back. Our next presenter this morning for our Elevations Geospatial Summer Series is a dear friend of mine, Karen Rogers with YGO. Karen's been extremely helpful, I think is the best way to say, for the state of Wyoming in implementing more GIS applications and whatnot, but I will let her go ahead. Remind everybody the meeting is being recorded and you will be sent an email with the recordings later. But with that, I'll turn it over to Karen. Karen, it's all yours.
Thank you, Pete. Good morning, everyone. I hope everyone can hear me okay. So without hesitation, yes, thanks to Pete and thanks for the planning committee for making the Elevations Geospatial Summer Series the success that it is. And thanks to our sponsors, of course. So I am Karen Rogers, for those of you who don't know me, and I am the Enterprise GIS and Data Visualization Coordinator for the state of Wyoming. And I'm going to talk to you for a bit about, give you an update on what's going on with NSGIC. And NSGIC, come on, exists to advance state-led geospatial coordination for the nation. And we serve as a national forum to develop future-oriented geospatial leadership and advance sound policies and practices for geospatial activities. So that's kind of the mission statement and vision that we have for NSGIC. And as you can see, well, I'll go back. So NSGIC stands for the National States Geographic Information Council. So it is primarily, an organization of the state GIS coordinators or GIOs and or equivalents. And but we do have members from state agencies. So like we have members of DOTs in certain states and Division of Natural Resources and such. And we really are a very fun, dynamic, diverse organization. And so one thing that I'm really proud of, if you haven't heard of the Geospatial Maturity Assessment, this is something that NSGIC has put out every other year since around 2000. And for a long time, it was just kind of, a survey asking states how they were doing on their state spatial data infrastructures. And we gathered the information, but we didn't ever really do anything with it or analyze it or put it together in any report. And 2 years ago, I was inspired by the Coalition of Geospatial Organizations report card for the National Spatial Data Infrastructure and convinced our NSGIC executive director to make it more of a thing. And so we pulled together a team of people and we developed grading criteria to actually assign grades to states. And so for the first time 2 years ago, we put that report card out that assigned, again, grades to states for the 8 framework data layers recognized by the FGDC And then we also just collected information on NextGen 911 and geo-enabled elections. And then we also, in addition to the framework layers, we also graded states on their overall coordination in the state. And if you haven't checked that out, the link down at the bottom in that bottom bullet is to the dashboard that we produced. And I will put a copy to the slide deck in the chat window so you can access all the links embedded in this presentation. But I encourage you to check out that dashboard because, of course, it's far more understandable and interactive in a map. And so for each framework layer, there's a tab with maps showing where you can click on states and find out their grades and see the answers that they provided to the questions for that theme. And, you know, it just makes it really easily consumable. And so, again, if you haven't seen that, I encourage you to check it out. And so this iteration of it is currently out on the streets for states to fill out and submit their answers, with the deadline being June 18th. And we kept things mostly the same. A few of the things we changed revolve primarily around the idea of open data and really pushing states to open their data up, publicly accessible, publicly available. And like in the example, for the example of parcels, if you have parcel data and it's not open to the public, then you will get automatically down 1 grade. And that's just reflective of the importance that we're placing on open data. And again, for NextGen 911 and geo-enabled elections, that's just informational at this point. And we see at some point, especially for NextGen 911, that we will at some point get to where we will grade states on that too. But we just felt like it's too young at this point, and you know, it's not as much of a thing in all states to be able to grade them. So the GMA is out, and last time we had 41 states provide responses to that. And so this year we're certainly hoping to get closer to the magic number of 50. And if we get a few territories, that would be good too. So the GMA, we expect to have the report out by the end of this year, summarizing this year's grades and any trends that we have seen from the last 2 years on that. So another thing that NSGIC is doing, and I apologize that the text is so small in these slides. I can make them bigger if you want me to, if you want to see them. But again, I'll make the link available. So the 3D elevation program, NSGIC is doing as a funded program with USGS. I mean, USGS has its own 3D program, with Carrie Lydic is going to talk about later today. But NSGIC has a paid program thanks to USGS, where we are working with states to develop 3D state plans and work with states to submit successful broad area announcement proposals, where states can, excuse me, get in a cost share agreement with USGS to collect LiDAR data in their states. And recently released from this effort is a new information hub. And again, I encourage you to go to that link because it has some really good use cases of how states are using LiDAR to solve issues in their states. So I know one such example is, excuse me, in Ohio, talking about orphan wells. So they got QL1 data in Ohio, excuse me, and used it to find orphan wells that are hard to find, you know, on the landscape. And then another example that will be posted soon is from Kent Park with Wolpert, who talked last week about their efforts with mapping cheatgrass using LiDAR. And so just good examples of how to think about how you can use LiDAR in really ways to sell it to your decision makers to make it worth the investment and, you know, justify the cost of putting up some money to get LiDAR for your state. So we're working on the year 3 plan and deliverables, and every month, let's see. So we have a webinar next month on acquisition strategy and plan of action for your LiDAR and state plans. And of course, the mailman just went by, so apologize for that. So along those lines, and this one is really cool, and I'm going to blow this one up just because it's just really exciting. And again, it was supposed to be Jeff Levin. It was Brian Stevens, I think, last week, who took his place and talked about a little bit about the elevation derived hydrography program that USGS is now starting in earnest. And so NSGIC also got money from USGS in a cooperative agreement to engage states and local governments, and of course, the private sector partners, to derive high resolution hydrography from 3DEP data. And so similarly to the 3DEP program, the idea is to work with states to develop best practices through pilot projects on how to use that LiDAR data to improve hydrography data, because we all know that water flows downhill. And so elevation is pretty critical to mapping where water goes and how. And we are sponsoring monthly webinars that are open to anyone. You don't have to be a NSGIC member to attend those webinars. You can go follow that link in the slide to register for those webinars. And those webinars are focusing on activities in different states. So last month it was focused on New Jersey. And then this next month it's focusing on how Alaska is using IFSAR data to improve their hydrography data. So really cool stuff. And just it's really fun to see the synergy that's happening between the LiDAR data and how the 3DEP program is filling in the country with good LiDAR data, and how we're using that now to produce better hydrography data. So it's just a really good synergy to see. So the next project that NSGIC is working on is called Geo-enabled elections. And the motto here is getting the right ballot to the right voter. And I'm going to blow this one up too, because it's pretty cool. So this is a program funded by the Democracy Voice Fund. And we've been doing this project for a few years now. And just recently we started this training webinar series with the Center for Tech and Civic Life. And the recordings are available, and we have, I think, 2 more weeks worth of those trainings coming up on Thursdays at noon. And so if you are interested in attending those, I encourage you to find that link and register for the webinars. And so we're wrapping up the first year of pilot projects, where some have been states, some have been just counties in big states like Shasta County in California, where they have learned how they can use GIS to quality check their voter rolls, their voter registration, and precinct boundaries, and making sure the right ballot is getting to the right voter. And it's focused on elections, but this has huge impacts on the whole redistricting process, and making sure that once those boundaries are redrawn through redistricting, that then a voter that might have been in this voter district is now in a different voter district, and so making sure that they're getting the right ballot given the new boundaries. So again, if you're interested in becoming a pilot in year 2 effort, then get in touch with Jamie Chesser, who will actually be speaking to us next week. She's going to talk to us with Mary Fulton, the GIO of Pennsylvania, and they're bringing in the Pennsylvania Secretary of State for their presentation next week. So I encourage you to tune in for that one, as it will be fascinating, I'm sure. And State Scoop, a media organization, wrote an article on the whole geo-enabled elections effort that you can follow that link and read up on it too. So another effort, advocacy effort that NSGIC is working on is the idea of providing better data to wayfinding companies. And so the idea is, how do we, as states, work with wayfinding companies like Google, TomTom here, Apple Maps, so that they are getting authoritative data in a timely fashion to help consumers use their navigation apps and not get in accidents. And this morning I was on a different webinar, and Frank, my colleague from New York, said, if you think about it, navigation apps are how citizens are interacting with state data the most these days. In other words, how many people go through a day without using a navigation app? And that's, they're getting that authoritative data, transportation data from your DOT. And so they're interacting with that data daily. And probably annoyed with it daily when it routes them wrong, or, you know, the exit number is wrong, or maybe they go down wrong way down a one-way street. An example in New York that Frank always brings up is bridge clearances. And so, you know, certain clearances are reported, but bridges are not all parallel to the horizon. They can be arched. And so the clearances can be different. And so trucks might be following their navigation app and then end up hitting a bridge because they don't know that it's not tall enough for their truck to go through. And so it really is a public safety thing, not to mention getting your packages and your pizza delivered accurately and on time. And so we're working with all these companies and with the USDOT to try to figure out a better way and, you know, an easy, cost-effective way to get authoritative data into the hands of wayfinding companies. And so the USDOT developed a work zone data exchange standard using GeoJSON format. And so they've developed this for work zone data so that, you know, on your app, you can see when a street may be closed because of construction, or, you know, lane is constricted because of construction, and when it's done and when it's expected to get back to normal. And so they've got that worked out. And so the idea is to figure out how we can extend that to include bridge clearances to begin with. And then eventually, when we have a complete national address database, then be able to consume address data so that that would be usable in wayfinding company apps. And we have a list of other data points that we would like to see, you know, built into this eventually. And those other things include road directionality, exit numbers, blanking on a few others, but, you know, other things include bike lanes, you know, non-motorized transit. So, you know, we're certainly going to take a while, but I think this is a really worthwhile effort that NSGIC is undertaking to try to improve that communication stream. And again, the idea is that states put their data in a consumable format through services so that they don't have to tell companies that they're there, and they don't have to, you know, pick who they tell. It's just out there, and those navigation companies can just consume that data, and the, you know, the updates are as streamlined as they can be. So hopefully that helps. Another cool thing that we're doing, I'm gonna blow this one up. So last year, NSGIC started working cooperatively with these organizations. So ERISA, NAPSIG, which is the National Alliance for Public Safety GIS, excuse me, NACHO and ASHTO, I don't remember exactly what their acronyms stand for, but they're Association for Public Health Officers and State Health Officers. But so, you know, the origin of the conversation was, how can we use, clearly GIS is being used to track the pandemic, to track the spread of the virus, but how can it be used more efficiently by the public sector to reduce duplication and to really put power behind the data, but get everybody using it the same, or, you know, not necessarily the same way, but share thoughts as to how it can be used better. And so we had a community forum last year and a GIS hot wash, where between that and this survey that they put out afterwards, there were like 1,000 people that attended that hot wash and provided feedback on the survey. And so from that, they produced the after action report, which is the third bullet there link. And that is a story map that, again, is super thorough and powerful and has a lot of good information. And then OGC, the Open Geospatial Consortium, put out an RFI asking for information on how GIS can be used to improve pandemic response. And some of the feedback they got was, clearly there's power in geo-enabling health data, but don't duplicate the health systems. So in other words, you know, you don't need to duplicate any data that's already being collected and aggregated by a Department of Health, but rather provide them with the knowledge and the tools to spatialize that data so that you're just visualizing it geographically instead of statically or just in spreadsheets. And another big takeaway is to geocode addresses on input. And so, you know, when you're getting a COVID test, you have to enter your address. And so if somebody's capturing the address, they should, you know, double check it through a geocoder then and there. Otherwise, you know, if it's wrong, then they've lost that opportunity to capture that address and validate where that person lives. And so again, just creating some efficiency to how address data are central and used to everything. And then there was a lot of talk about spatial resolution and what is an adequate resolution to use when you're talking about COVID cases and case counts. And a lot of states were doing it by zip code, no, doing it by county and or by zip code. And it just wasn't helpful. And so, you know, recognizing that there has to be HIPAA protections, but going down to the zip code, going down to the census block when that's possible. I think Wisconsin was the first state to do that, and it just proved much more effective and really dials in on specific hotspots and areas of concern much more effectively than doing it by just county or zip code. So a lot more discussion on that, but coming up, we have, sorry, I can't read that because it's too small. Things coming soon are model practice survey, and then the pandemic GIS playbook. So this is something, the playbook is, so there is a pandemic playbook, now we know, and that's used by, you know, public health officials. And so the idea is to use, integrate GIS into that pandemic playbook so that, again, when this happens again, people are more prepared. You know, it's hard to build that GIS response in the middle of it. It's better to put those plans in action and be ready and prepared for it before it happens, so that you know, your response is GIS enabled from the get-go next time. And then a few other items with the pandemic GIS task force. Again, cross-referencing from general pandemic playbooks, and again, talking about the data availability and trying to put some consistency with how data are aggregated at the state level, how they're then communicated back out to the public through dashboards and apps, how they're aggregated to the smallest geographic units possible. And again, how you can use that data then to inform the response and understand more what's going on at that local scale, whether it's, you know, to be able to combine, you know, COVID cases with your demographics and your comorbidity prevalence and other issues that affect how people engage with the government, like your voter turnout and your census form return. And so again, if you can do that at the census block level, that's going to be consistent across that. Other things that we're looking at for data and impacts from COVID include businesses, you know, all the businesses that have closed down, and what happens to all that business space, all the real estate that is now vacant, and what happens to those urban centers where businesses have closed down. What do we do with all that office space now? And the last thing on this is one thing that you might have heard of is the idea of using wastewater sampling as an early detector for hotspots. And I know this was done at CSU, and it was done in Powell, Wyoming, and done in a few other bigger urban areas too. But the idea is to test the sewer system for COVID virus, and then you can kind of trace back. If it's here, then you can use the parcel data and see, you know, what community is within that sewer shed, and do some contact tracing and just try to nip it in the bud. So again, GIS is of course critical to mapping out the outbreak and mobilizing people to try to keep it contained. So lastly, a few other neat collaborations that NSGIC has going on include, we are hosting quarterly meetings with the National Tribal GIS Council, where we're talking about the idea of creating a national mapping application for missing and murdered Indigenous people, which used to be missing and murdered Indigenous women, but they have expanded it to just be for any and all people that suffer such tragedy. And so we've had a few of these quarterly meetings already, and it's really neat to meet with tribal partners and, hear their pain points and just open those lines of communication. So there's a lot of opportunity there. Another fun area of conversation is we've been having some meetings with this Chief Data Officers Network, the CDO network, and are talking with them about important topics such as data sharing and data governance, and how to work together from really data science perspective between traditional data and spatial data. And so that will be ongoing. And then another really cool thing that is going on is we're meeting with OGC on, we're creating a workshop for Geospatial Data Act implementation. And so you may recall 3 years ago, I think in 2018, the Geospatial Data Act was passed, which codified FGDC and the framework layers, and puts in a reporting requirement for federal agencies for how much money they are spending on geospatial data. And it requires them to work with partners at the state and local level to improve the geospatial data assets. And of course, it's been, things are happening, but there's a lot more that could happen. So we're having a workshop and 2 workshops this summer to work with federal partners on how we can really make it an effective and successful implementation of that law. So, and this is just scratching the surface. I'm almost out of time, and so I would stop here and just see if anybody has any questions, and encourage you to register for any of those webinars and find out more about NSGIC. Those of you who know me know that I can't say enough good things about NSGIC, and it's just an amazing group of people, and we do amazing things. So I will.
You do have a couple questions there, Karen. I think the most pertinent one is the link for the Center for Tech and Civic Life upcoming event.
Yeah, I'm sorry, I realize I don't have that in my slide deck. I will put it in the slide deck and then email it out.
Yep.
I apologize. Oh yeah, Dave, yes, the same thing. Dave, go to the NSGIC website and you might be able to find it on the NSGIC website. And as far as state coordination for Colorado, I have
Hey, you're not alone.
I've heard nothing.
You're not alone.
Yeah. I'm sorry, I don't have any inside information there. It will be interesting with the GMA to see if there's anyone home to fill in the GMA for Colorado. Who knows? I don't know what to tell you. It's unfortunate, to be sure.
And especially with all this infrastructure spending they're talking about, you would think that I can make an argument that having a strong central coordination for GIS activity at state level could be a very, very valuable thing for infrastructure.
Absolutely, yeah. And one thing I'm glad you brought that up, Pete, that I should have commented on is the idea of next generation 911. That's definitely one of our bigger advocacy topics in NSGIC. And with the Lift America Act, there is $15 billion, that's with a B, potentially out there for the next round of NSGIC, Next Gen 911 grant money. And in the draft legislation, it stipulates standards for the technology running like the EZNets, but it doesn't say anything about the standards for GIS data. And so NSGIC is working with ERISA and NAPSIG and NINA to try to make sure that some of that is incorporated into the legislation, so that the GIS data actually come together because they're all adhering to standards. And we know the value of data standards and using standard protocols. So hopefully that will get into the legislation, and hopefully that legislation is passed so that we can all benefit from billions of dollars to stand up our next gen 911 systems. And Dave, I'm not sure I understand your last question in the chat. Where's who, as far as Colorado specifically for the leadership, and who do we contact?
Dave, you can talk now if you want.
Yeah, feel free. Again, I don't know. It's been kind of a vacuum in Colorado since John left, and I have heard nothing.
So who is it that we need to contact?
Here in
Is it our
Colorado?
elected officials? Is it
Hmm.
the,
Yeah, contact your governor, your legislators, your reach out to your CIO. I mean, those are the people who make it happen, and they need to understand. And this is the effort that I've been on in Wyoming for years, is trying to whack people up the head and make them realize that GIS is central to a efficient government, and much better at implementing government services more effectively and efficiently. And you're just, hamstringing yourself without having that position, without having the coordination.
so Pete, do you know of any advocate that we have?
No,
There is no advocate. Okay.
not that I am aware of, Dave. And I think, and I remember some words of wisdom from, we all know who he is, and I just can't remember his name. And he relayed to me, and this is back in the late 90s. He said the problem with Colorado is everybody's too independent.
Yes.
Every
Truly.
agency is a power unto themselves, and that's all they want to preserve. They really don't want to work together, and they certainly don't want to give up anything that might cut their budget, because budget is God.
Okay, well, we'll nibble around the edges. Thanks.
Yeah, and good luck. It's definitely an uphill battle. So Dave, I just found that link, and I'll put it in the chat window for the webinars with the Civic and Tech Life Center for Civic and Tech Life.
Thank you.
Yeah.
Well, Karen, I think we're out of time for you, but thank you so very, very much. Appreciate the presentation. We're going to go ahead and now scheduled for a 10-minute break. I have in my program from 10:30 to 10:40. So what I'll do is I'll pause the recording, and I will fire things back up at about 10:35. Thank you all very much.
Thanks, Pete. Thanks, everyone.
Well, welcome back, everybody, to our continuing presentations for the 2021 Elevations Geospatial Summer Series. We have our next presenter from the USGS, Carrie Lydic, and she's going to be talking to us this morning about the 3D elevation program that the USGS has been sponsoring for the last several years now. And with that, Carol, I'm going to turn it over to you. I'm going to unmute you. Well, I'm going to try to unmute you. Let's see.
Okay, how about now, Pete?
Now I can hear you. Thank you.
Okay, great. All righty, well, thank you, Pete. And I'm going to go ahead and share my screen. Okay, and just as a check, Pete, can you see my slides okay? All right, okay, so Pete, can you confirm that you can hear me okay and see my slides okay?
Yes, I can see and I can hear you fine.
Okay, great. Thank you. Hello, everyone. Thanks to GISCO and YGO for time on the agenda, and thank you for attending the presentation today. My name is Carol Lydic, and I work for the U.S. Geological Survey as the National Map Liaison for Colorado, New Mexico, and Wyoming. And as the liaison, I work in collaboration with the geospatial communities in these states on common interests, which also further goals and objectives of the National Geospatial Program. The National Geospatial Program includes the 3D elevation program, which is called 3DEP, and that's the topic for the presentation today. I'm going to be talking about the program overall and also provide an update on LiDAR acquisition projects for Colorado and Wyoming. You might be familiar with the long history of the USGS in providing elevation data, first through contours on our topographic maps and later by digital data in the National Enhanced Elevation Data Set. The 3D Elevation Program, or 3DEP, is our current effort to provide national elevation data. 3DEP goals are to complete acquisition of nationwide LiDAR with IFSAR in Alaska by 2023, to provide the first ever national baseline of consistent high resolution elevation data. And that's both bare earth and 3D point clouds collected in a time frame of less than a decade. Also, to address federal, state, and other mission critical requirements, realized return on investment of 5 to 1 and a potential to generate $13 million per year. Leverage the expertise and capacity of private mapping firms, achieve a 25% cost efficiency gain, and completely refresh national data holdings. The lower left corner of the slide has a table, and it shows the top business uses ranked by the total benefits that were identified by National Enhanced Elevation Assessment participants. When benefits were identified as a range, the conservative number represents the lower end of the range, and the potential number represents the high end of the range. The land navigation benefit is realized from vehicle fuel reductions that can be achieved by intelligent vehicle navigation systems. There is a status map in the lower left corner of the slide, and this is how the status map for the US would appear in 2023 when 3DEP goals are met. Airborne LiDAR data are collected from aircraft by using sensors that detect the reflections of a false laser beam. The reflections are recorded as millions of individual points, collectively called a point cloud, that represent the 3D positions of objects on the surface of the Earth. Objects can be buildings, vegetation, infrastructure, and the ground as examples. IFSAR is a type of radar which has lower accuracy and is less detailed than LiDAR, but is the preferred method for data collection in Alaska due to its ability to penetrate cloud cover and operate from planes flying at higher altitudes and speeds. LiDAR is transforming mapping by providing highly accurate maps of the Earth's surface and three-dimensional data of all the natural and man-made features on the surface. So what constitutes 3DEP quality data? The deliverables for any given project must conform to the most current published USGS product specification for LiDAR and derived products. This can be found at www.usgs.gov/3DEP/LiDAR spec. All new projects that are part of the 3DEP program must adhere to the USGS LiDAR-based spec. The spec details how LiDAR projects must be acquired, from determining vertical accuracy to the classification scheme required for the LiDAR point cloud and everything in between. The current version is 2020 revision A, and a history of all the revisions is available dating to version 1.1 from August 2012. The spec that was last updated in August 2020 includes some major changes, such that, for example, that we changed the version naming for clarity and improved version control. We added the requirement for swath separation images and metadata. We added a requirement for photographic checkpoints and expanded vertical accuracy requirements to include ground classification points, just as some examples there. The spec in of itself could be a whole presentation. So I would just encourage you to check out more information at the link that's provided here on the slide. In addition to the requirements that are outlined in the USGS LiDAR-based specification, LiDAR data and derived products will meet or exceed the current definition of quality level 2 as follows. Classified LiDAR point cloud data with a minimum point density of 2 points per square meter, a nominal LiDAR pulse spacing of no greater than 0.7 meter, and a relative vertical accuracy of no greater than 10 centimeter root mean squared error. The United States Interagency Elevation Inventory is a nationwide listing of known publicly available high accuracy topographic and bathymetric source elevation data for the United States and its territories. The inventory provides a single resource for information about all known, completed, and in progress public domain elevation data. The URL for the website is shown here in the bottom right corner as coast.noaa.gov/inventory. And the inventory is maintained by a number of federal agencies, and those are the Federal Emergency Management Agency, US Geological Survey, National Oceanic and Atmospheric Administration, US Department of Agriculture, Natural Resources Conservation Service and Forest Service, US Army Corps of Engineers, and the National Park Service. This is how Colorado currently appears in the US Interagency Elevation Inventory, or USIEI. As you can see, there are green polygons covering the state, which means that 3-depth LiDAR projects have been completed or are in progress. Data is being contributed for possible use by 3-depth, or there is other publicly available LiDAR data. Not all publicly available data meets 3-depth specifications, and the USIEI has a field in the project information which indicates the 3-depth status. The USIEI is updated every spring and fall, and if you were to click on the project name here, which in this case is San Luis Juan Miguel, then you can view information about a LiDAR project, such as the status of the project or the quality level of the LiDAR data. This is how Wyoming appears in the USIEI. And Wyoming also has green polygons, again, covering most of the state, which means that 3-depth LiDAR projects have been completed, they're in progress. Data is being contributed for possible use by 3-depth, or there is other publicly available LiDAR data. And again, not all publicly available data, that public data is meeting 3-depth specification. There is a new LiDAR project which will result in QL2 LiDAR for Larimer County, or Meade County, excuse me, which is located in the southeast corner of the state. And in this example, the North Converse, Wyoming project is shown here outlined in red. 3-depth is built on partnerships, and there are 2 paths for LiDAR data acquisition. USGS and other feds may partner via interagency agreements, and the broad agency announcement is the vehicle for soliciting partnerships from non-federal partners. It is a fair and equitable process that allows state, local, tribal, and private organizations to propose data acquisition projects. And together, the 2 acquisition streams form the 3-depth acquisition plans for the year. This is the map of 3-depth FY21 partnerships as of April 14th, 2021. The map shows the geographic extent of existing and in progress 3D data acquisition projects. FY21 projects are the result of partnership projects awarded throughout the FY21 3D broad agency announcement and through ongoing federal coordination by the 3D working group. The data is quality level 2 or better LiDAR data with IFSAR in Alaska, as defined in the USGS LiDAR base specification version 1.2 or later, and the data is or would be publicly available. So an explanation of that legend is that the striped lime green polygons are planned FY21 3D LiDAR partnerships, and those are subject to change. Lime green polygons indicate FY21 LiDAR partnerships, and dark green indicates in progress or completed LiDAR partnerships, and then dark blue indicates IFSAR and is for Alaska. The 3D products and services available through the national map include digital elevation models at various horizontal resolutions, elevation source and associated data sets, an elevation point query service, and bulk point query service. All 3D products are available free of charge and without use restrictions through several different platforms, such as the National Map Viewer and Download platform, LiDAR Explorer, available as an ArcGIS REST service that can be used in applications such as ArcMap or ArcGIS Pro, and also via folder structures for download via FTP or Amazon Cloud Browse. For example, LiDAR Explorer is an intuitive application to enable the search, discovery, and visualization of LiDAR data and DEM products provided by the NGP. Here's an example of the information displayed near Cortez, Colorado. On the right side of the slide, you can see that the Colorado Southwest NRCS project includes coverage of the Cortez area and a list of the LiDAR point cloud files, which is available for download, is partially shown in the lower right corner. Understanding the complexity and richness of the national map is now made easier with the public availability of web-based training videos on a variety of topics. And over 40 videos are currently available on YouTube. A new series of lessons on using LiDAR data in various software environments is in progress, such as for ArcGIS Pro, Global Mapper, and LP360. And other topics include the National Map Viewer, downloading data from the download client, using the web services, Earth Explorer, the National Hydrography Dataset or NHD, Watershed Boundary Dataset, and NHD Plus High-Res. Well, thanks everybody for attending the presentation today. My email address is clydic@usgs.gov, and I'm happy to answer any questions today or through email. So, and thanks again to Gisco and YGO.
Questions for Carol? Don't be shy.
Hey Pete, there's a question on the chat I noticed from Steve.
Oh, there it is. Yep.
Okay.
Carol, can you see that from Steve Lohman?
He says to all panelists, he says, can see slides. I don't know if that was a question for me. Oh, he was just confirming that at the beginning of the presentation. Well, thank you.
Well, and also the 3D map of all Wyoming was shown as dark green, indicating it is done, but on the LiDAR Explorer, the data is a patchwork. And Steve's question is, when will data collected in Wyoming be available?
Okay, so that there are a number of things that are referenced there. So the map that the information I was showing in LiDAR Explorer, I think there's some confusion there because it's actually in the U.S. Interagency Elevation Inventory, where I was showing that Wyoming is almost totally covered with the green polygons. The extreme southeast corner, that was not shown as green because as of the last update of the information in the USIEI, we had not yet defined a project there. And since then we have. So that's why the national map that I showed for the 3DEP program, which is the status as of April of this year, that's why Wyoming is shown as being fully green, meaning that, as I explained before, projects are either in progress, they've been completed, possibly we're working with another entity to hopefully contribute their data for use by 3DEP, and there may also be some publicly available data, which may or may not meet 3DEP specifications. And so I don't know if I cleared that up, but if I didn't address that, please let me know. And you asked me, when will data for Wyoming be available? That's a big question because there are a number of projects that are in progress. As I indicated, we have a new one over that southeast corner of the state. And I would be happy to converse with you further beyond this presentation for any particular area where you might be interested, in terms of, a particular county or something like that. We could take a look at that together.
Great. Well, Carol, thank you so very much. Like I say, you've done an excellent job with the fact that there's no questions. That's how I always interpret that. And your information is available to everybody and will be available, and they can contact you like you suggested if they have any questions. So we certainly appreciate it.
Okay, thanks, Pete.
And thank you. Okay, we're staying right on schedule. It's 11 o'clock. And so our next presenter, Andy Bohnhoff with the Platte River Analytics, and I hope I didn't butcher your last name, Andy, too poorly. But with that being said, I'm turning it over to you. You're a presenter. You can share your screen. You can show yourself.
Okay.
I'm going to bow out of the way. Thank you.
Sounds good. Thanks, Pete. I'll share my screen for now, and then I'll turn my video on if there's any questions later. So let me go ahead and share my screen now. Okay, should be good, Pete. If you keep my screen, stop me, else I'm going to keep on going. So hi, thanks for joining today. My name is Andy Bohnhoff. The title of my 20-minute presentation today is Project Collaboration with Esri ArcGIS Online. And I'm going to touch a little bit on the collaborative environment within ArcGIS Online. I know for most of you, it's probably not going to be too earth-shattering, but I'm hoping to show a couple of kind of new widgets and a couple old widgets in ArcGIS Online, and how they can be used across a company. I will get into a little bit of a live demo today, so I'm not usually too big on slides. So I'm hoping to do a little bit of live demo and kind of show you what I've been working on, and hopefully you guys can pick up a couple of things. So just a little bit about me. I currently own a GIS consulting company called Platte River Analytics. I have my bachelor's degree from the University of Illinois, my master's degree from the University of Denver, about 15 years experience with GIS, 10 of those being in oil and gas. I was most recently with Anadarko Petroleum here in Denver, where I spent about 6 years as a GIS analyst. So the presentation today, I'm going to provide a problem that a solution of mine or a client of mine had, and then kind of how we address that problem together. So after we talk about this for just a couple of minutes, then I'll switch over to ArcGIS Online and demo some of the results. So the client is a large national home building company with dozens of offices across the country. They were looking for a spatial platform that allowed various teams to share data, make notes, add files, just kind of in general offer a more interactive, collaborative environment that they could all work in. In the past, they used a combination of PDFs, Google Earth, they emailed links, they had handwritten notes, Post-it notes, just any kind of form of project notes and statuses that they could think of. And it seemed like every office was different. Some offices would, email KMLs back and forth. Other offices would just email notes and links back and forth. And it got to be kind of a disaster for, as they grew, they had more offices, more people, everyone had their own way of doing things. So that really their form of data exchange and project communication, it differed so much from office to office that it kind of started to become an issue. Another thing was the exchange of static data was an issue too. So if one landman emailed another landman a KML, then that KML was almost immediately out of date. So if they emailed it a week later, it may be the notes or statuses had changed and nobody had really realized it. So the solution that the client and myself came up with was to move all of their spatial data, which consisted mostly of KMLs and a lot of different Excel tables. We moved that into an Esri format and then published all that data to ArcGIS Online. So then what we did after we published all the data to ArcGIS Online was we built an application using Web App Builder. And that allowed them to search on project name, add notes, add statuses, upload PDFs, upload other attachments. And then they're able to share that data interactively and collaboratively with the rest of their team, with the rest of their office, really with all the offices that they had across the country. So, if one analyst uploaded data in San Francisco, another analyst in New York City could see that data within seconds. So it really helped them to build a very collaborative environment that they really got to enjoy. So as a result of the automated mapping platform, users could view dynamic data and updated data. Project data, notes, and statuses could easily be relayed and updated. And then the link to the map was dynamic, and the client no longer needed to email attachments and site photos. So really, it was a big win that they got off of Google Earth. They got away from emailing links and notes and statuses and whatnot, and kind of moved into a more centralized environment that they could all use pretty easily. Okay, 2 slides is enough for me. So I'm going to get it here into ArcGIS Online. I'm going to show you just a couple of things really, because I don't have a whole lot of time to really get into the nuts and bolts of this whole application and map. So the first thing I'm going to do is show you a little bit about this hosted feature layer here in ArcGIS Online that I created. So first of all, I'm just going to kind of show you how exactly I built that hosted feature layer, and then I'm going to show it in the application just to kind of show you how it works. So first of all, I'm going to come in here, and this is just going to be an example. I'm not going to go through all of it because I've already done it. So I'll show you what the end result kind of looks like. First of all, here in my content, I'm in my group layer for elevation geospatial. I'm going to go to create and create a feature layer. So Esri actually has dozens of different canned feature layers that you can choose from. Here's all of them right here. So if there's already one that fits your needs, maybe it'll work that you could just download that one and use that for a feature layer. I usually like to build my own, which is here and build a layer. So you can see it gives you lines, points, polygons, all the above, tables, whatever. For this particular project, I'm going to go into polygons and hit create. Go ahead and hit next. This project that I'm doing for you guys today was just primarily around the Denver area. So I'm going to set the map extent for Denver, and this will be good enough for now, and hit done. So it takes a few seconds to add. So, once I give it a title and give it a tag, it's actually going to create a hosted feature layer for me. It will have roughly a dozen or so fields that adds automatically. But then I can come in and actually start adding new fields to this too, which is pretty useful. So once this loads here, you can see that there's here in data. And if I come over to fields right here, that's what I was looking for. There's already 9 fields already added to it. Now, the powerful part is you can add your own fields to this hosted feature layer. So if I come in here, let's just say name, I'm going to give it a display name of site name. String is good. 256 is good. Add new field. I'm also going to add, just to show, I'm going to add a status field. hit add new field. So I can come in here and start adding new fields in my hosted feature layer, which is extremely useful. Now, the one thing I wanted to show you guys in here that maybe some of you didn't know before is once I add my names here in my hosted feature layer, I can click on, for instance, status and actually create a list inside of here. So and this is why this is important is if you have multiple users across the company, you don't necessarily want them each adding their own statuses. So for this particular client, what I did was I only allowed them to use 3 different statuses. That way they couldn't fat finger something. They couldn't kind of go off on their own and create their own statuses. You know, they kind of had to follow a template, which I found useful. So just keep in mind, the main thing I wanted to show you is that you can build lists inside of your hosted feature layer fields. So now I have a list of values, so they can, whenever they use the hosted feature layer to build a new polygon, they can only use these 3 statuses, which helps a lot for symbology. It helps a lot for keeping good tabular data. So just kind of something I wanted to show you, that you can do that from multiple. So if I had statuses and if I had client or something like that, I could add a bunch of different lists in here for my values, just to make sure it all kind of stays the same across the company. Okay, so that's what I wanted to show you for this part right here. Now I'm going to get over into the application that I built. So normally I would build a hosted feature layer, then I would add it to a blank map and start adding my data. Just because I'm a bit limited on time today, I'm just going to get into the app and show you what I created. I didn't add much data to this just for simplicity's sakes, but if you got into a blank map, you could pretty easily add, county outlines, state outlines, city outlines. If you need gas wells or whatever you need, you could add it pretty easily in a blank map and then create this application. But I skipped the map part and went straight to the application. So I just wanted to highlight really a couple different widgets here in ArcGIS Online Web App Builder. The first one is the search bar, obviously pretty self-explanatory. I have it set on the project sites, so the company can come in here and search project sites. So if there's a certain project they want to search for, they enter it and it'll zoom them right to that project, which is very helpful for people that are not familiar with the different sites. If they have no idea where a certain construction site is, they can just enter the name and it'll zoom it right to them, which is super helpful. The other one is this info summary widget over here. And why this is nice is, as a lot of you probably know, you can't do much grouping in ArcGIS Online, which is kind of a pain in the butt. So the way around without the grouping issue, I have found is this info summary widget here. So it's dynamic. So as I zoom in or out, this number is going to change depending on how many sites I have. Now if I click this down button, it'll show me all my project sites that I have, which is super useful. So I'm going to click on this Chatfield Estates one. It's going to highlight it. I can click zoom to. So that makes it really useful for, once again, if maybe you don't even know the name of the project you're looking for whatever reason, you can come over here to info summary, find it in your list, and then zoom to it pretty quickly. Okay, so this is just kind of a random site that I created just for demo purposes. I'm going to click on the site, and this is kind of the collaborative environment I was talking about. So I enter a site name, notes, and status. Now, one thing that's really useful with this hosted feature layer is I can also add attachments in here. So if I click on my site plan JPEG, it'll open up the site plan. So I found this very useful for a lot of my clients, that I can add JPEGs, I can add Excel sheets, I can add web pages, Word docs, really whatever kind of attachment you have, you can add here in this polygon layer, which if you've ever tried to work collaboratively with multiple different people within a company, you probably know that a lot of JPEGs and site plans and whatnot get emailed around quite often. It's super nice just having a list of attachments here that everyone can utilize in a map environment rather than an email environment. I enjoy this feature quite a bit in Web App Builder, is adding attachments. So that is one I've created. And I'm also going to show you how to edit that real quick. So if I'm looking at this site right here, here's my edit widget over here. If I activate my edit widget and then click on my site, then I can edit all this info in here too. So this once again plays into the collaborative environment. So I can edit site name, notes, statuses, add attachments right here by choosing a file. So just imagine if you're working for a home developer and you just spoke with a property owner or a property developer. So you would want to come in here after you spoke with them and add a new note for the rest of your team to see. So I could say just something like maybe 5.6, spoke with developer, hit close on that. And the next time anyone else comes in here and clicks on this polygon, they'll be able to see the note that I added. So that you don't have to worry about emailing each other or pinging somebody. It's already going to be on here dynamically for the rest of your team to see. So anyone can kind of immediately come in here and see that edit that you made. And so real quick, I'm going to exit out of here, come over here to layer list. I did download parcel for Douglas County. I'm here south of Denver. I live up at Island Ranch, so I know the area pretty well. So before I wrap up, I'm just going to kind of quickly show you how easy it is to add a new project site and how easy it is to use that hosted feature layer. So I turned on Douglas County parcels. I'm going to zoom and find a real easy site for me to outline. So this looks like a good square one here. So I'm going to open up my edit widget again, click on my new feature and just outline. Let's say, for example, that this parcel is being developed into an apartment complex. So I'm going to create a new polygon, double click to exit. Then I can enter my site. So let's just say Sheffield Apartments, notes, none right now. Status, it's being looked at. So let's say due diligence. If I had an attachment, I would add it right here and hit close. And since I had set my symbology at a map level, it's automatically going to set it as due diligence. So if I came in here and changed it to construction, so if I open up my edit widget, click right here, change that to construction, hit close, it's automatically going to change it to red. So that's some of the things you can do kind of in the mapping environment beforehand to kind of make it a little bit easier on the rest of your team for sharing data, and especially in this case, sharing statuses of different projects. So I know that was very quick, but since I did only have 20 minutes, that was kind of what I was wanting to show today. So really the main point for my presentation was just to kind of show that, a single GIS analyst or even a small GIS team can help to create a collaborative and interactive environment for their entire company. It used to be that you would need a handful of developers and coders and front-end GIS analysts, back-end GIS analysts to create this type of application. And really now you can get away with just a single person, even just a part-time person creating these type of applications. Obviously a little bit of training for the rest of your team, but once it's done, ArcGIS Online, it makes it super simple to add, edit, share, spatial, and tabular data. So, it's pretty easy for a small team now to kind of serve GIS data interactively to hundreds, if not thousands of people within an organization. So with that, I'm about out of time. I will leave a couple minutes for questions if there was any. So thanks for attending the presentation today. If you have a question, comment, or want to discuss your next GIS project, feel free to let me know. Like I said, Andy Bohnhoff, abohnhoff@platteriver.com, and I'm with Platte River Analytics. Thank you.
How about some questions for Andy? Well, I have one. So creating all that stuff, Andy, the way you were demonstrating, how credit intensive is that with the credits that you get with your AGOL account?
Yeah, so the client that I kind of mimicked this presentation for, they use between 5 and 10 credits a day for all of their mapping. It's really not credit intensive at all. A couple dollars a day in credits they use, and that's multiple users, everyone editing, downloading attachments, whatever. So honestly, it's not bad at all, which is kind of surprising with a lot of Esri tools. But
yeah,
as long as you're not uploading and downloading data all day long, as long as you're keeping everything within the GIS Online environment, it's actually pretty inexpensive to get something like this going.
And kind of a follow-up on that, how much time with your clients do you spend training them and getting them accustomed to this form of collaboration?
Yeah, as long as you're only trying to train on ArcGIS Online, 2 to 4 hour training is good enough. If you need to train on how to publish data and how to set your symbology in ArcGIS Pro and that type of thing, that's maybe at a couple of days to a week. But if you're keeping, and what I like to do with my clients is keep everyone trained within ArcGIS Online. So as long as you're only training on ArcGIS Online, it doesn't take much time at all, especially for just the users, or someone just editing a little bit of data. I only train them on the application. I don't really train them on how to create maps or how to upload data, stuff like that. So it really doesn't take much time at all to do that type of training.
You don't bore them with geographic coordination systems or schemes, right? Or
I don't want them to know that. Yeah, they'll just screw it up.
And how do you like working for yourself?
I like it a lot. I spent about 10 years work for various oil and gas companies, and I love the entrepreneurial side of owning my own company and doing my own taxes and keeping timesheets and stuff like that. And I spent about 10 years in oil and gas, but I love the fact that I can work for solar companies and home building companies and real estate. And I love how many different things I get to see every day now.
And I will make a comment. The one thing that's always been my big issue is that people think they want to get into GIS, a county or a company, whatever, and they're thinking, oh my God, we got to hire all these people. But really, once you get yourself organized, and you mentioned it, and I kind of cringed at the idea that, oh, you can just have a part-time guy, right?
Yeah,
I mean, we all want full-time employment.
Exactly.
But it is true. There's so many examples, I think, of overspending, over implementation.
Yep.
That a lot of, like, say, companies, people get scared of the cost.
Right. Yeah.
And it's not that bad. I mean,
and kind of what I meant by the part-time guy is you could have someone doing 20 hours a week in IT and 20 hours a week being the GIS analyst. So you don't necessarily have to have 40 hours a week GIS analyst. A lot of times you can get by with having 20 hours in the field, 20 hours behind a computer, or whatever it might be. It's especially Esri, and I know there's a lot of other platforms, but they make it pretty easy with their drag and drop environment anymore to kind of build pretty cool and useful tools for sure.
Their ArcGIS Online environment and the whole thing has become drastically improved over the years. It really is a delight, and it's an easy thing.
They make it very easy for non-developers like myself to build very powerful tools and very powerful applications. You don't have to know much, developing your code. Obviously, it helps if you want to build your own widgets or get into kind of the JavaScript or something like that. But for people like myself that don't know much, kind of programming languages, it still is very easy and useful.
All right. Well, Andy, really appreciate your time and your presentation today.
Thank you.
And stuff will be posted online, and everybody will get an email as to where they can find it. Thank you so much. Really appreciate it.
Thanks, Pete.
Okay, I am looking for Dave Siddle, excuse me. And I do not see him anywhere. Let's see what's happening. Well, maybe we should start our social hour early, huh? I'm going to certainly pause the recording for right now until I.
Workshop on ProStar's Point Man. So just really wanted to kind of lay out some of the information of what we're going to be going over and where Point Man is. So this is actually a better opportunity with the people on board to if you've got any questions, you want to raise your hand, to talk about the different workflows. So with that, I'll open the floor to see if anybody has any questions. And so for tomorrow, Point Man is a field software that CDOT has adopted for their right-of-way mapping. Everything goes into plan and profile. I've been on the beta team starting a year ago, May. There is a mandate that came out in January 14th of this year, where anybody that's collecting data in the CDOT right-of-way has to be utilizing the Point Man workflow. It's done tremendous things as far as creating continuity of data, consistency of datums, coordinates, projections. There are 95 pages of the TMOS code, all built in. So there's a really, really terrific workflow. And then tomorrow, we're going to be talking about the next generation of Point Man, which is Point Man Pro. And this is a enterprise system similar to what CDOT is using, but that anybody will be able to integrate their workflows. And, it's really in that subsurface underground engineering workflow, plan and profile, any of these pieces. So it's pretty exciting stuff. Pete, real quick, how long do I have left so that even though I was tardy, I don't want to go over and just want to make sure that we're on
I've
the
got
same
you good
page.
for, 11 till 11:50. So you've got 20 minutes easy.
Okay.
And
So
we can even go longer if we need.
all right, I'm going to go ahead and pull up a PowerPoint here. So if anybody has any questions on this or specific, go ahead and jump in, and I'll get us. I'll show you some of this overview that we have on the CDOT project.
I'll keep an eye on questions in any chat and relay that to you as you.
Okay. So I'm going to share my screen. All right, so can you guys see my screen okay?
Now we see it.
Okay, I'm going to leave it on this screen just because there's some audio in the background. So I know it's not our preferred, but so this is a presentation did with Rob Martindale. He's the program manager for CDOT, and he's spent about the last 6 years bringing this new field data collection into CDOT. There's a lot of struggles in how do we make these changes. And, the biggest reason, obviously is to get continuity of data. And, there's a lot of problems with having, old data, CAD files that had just been, digitized. And there's just a lot of issues in getting that consistent data. So his goal in this was, how do we bring all of these pieces together? So legislation, Title IX safety came out, the 9-15, and this really addresses a lot of these types of issues in, how do we make all of these things easier? It ties it into the Colorado 811, making certain that we're collecting underground facilities electronically so that we're actually getting these locates, all of this information that, we're always looking for. So the rules and regulations came out, it's, permit 112 in the as-built drawings. So this is what came out in January. And, the key really is, marrying the survey data along with mapping data and getting that high accuracy, but all the attributes, and that we also now have the ability to pull in locates. So whether you have an RD, that's a blue model, or a Metrotech, the yellow, the VLOC series, we can make all of these things work together so that we're actually capturing all of this electronic data. So it is a cloud-based solution. So if I'm in the field collecting the data, and as I'm hitting, done on those points, it's actually being updated in a real-time environment in the CDOT atmosphere. So again, all of these pieces coming together are really, really powerful. So for CDOT in the right-of-way, everything is in a sub-inch environment or a 2-centimeter environment. And what we're looking in here is that these are the details of data that are collected. And so for the field tech, it's all real-time corrected. So there's no excuse for bad data, and we know exactly what we're getting in the field. So again, continuity of data and all of these pieces is what's important. So as I said, the real dream here is marrying the GIS data, features, attributes, all of that, with the high accuracy that we normally get from a survey environment. So we're capturing both of those pieces. Now, on the GIS side, the things that we really like to have are, all of that additional information. So we get photos, we can use a voice to text, we have imagery where we can sketch right on. If there's a CDOT inspection form that is required, that's automatically attached. We're filling out this data. And so we have all of this information that is available if we're doing observations, or, as that field tech is collecting the data. All of these pieces are available to us. So we also get all of the supporting documents, so where we always used to bring in field books and, line drawings and, blueprint, all of those are now in the field on your device that you can reference while you're in the field. So again, how do we streamline this? How do we make all of these pieces easier for the field data collection? How do we put all of that stuff together is really that big strength. Hey, Pete, I just want to make sure that you guys are seeing my screen change and just not the main screen with Rob and I on it.
No, we are seeing your PowerPoint presentation.
Excellent. Good. It's awfully quiet over there, so I just wanted to make certain. So, this all comes into the end goal of, bringing GIS data into that engineering design. So we have all of the information that we collected and, that we want to be able to bring into these deliverables. So we have, the GIS that was collected, we have all of the information, and that goes straight into a CDOT microstation Bentley CAD environment. So again, we're streamlining all of these workflows. And then at that point, the final deliverable is able to go out for a PE or something. Say, okay, this is what needs to be done, or this is what was done. The traditional method of closing permits, collecting this data, would be, if I was the field tech, I would go out in the field. If I'm in the right of way, I've got a map book, I have my paper permit, I collect the data, whether it was just a bore or maybe it was a gas or water line. I come back, post-process the data, give it to the CAT operator. The CAT operator brings it into a microstation or Bentley environment. They give it to the GIS person. The GIS person then goes to the website. They update the permit. And that can take weeks to several months. And there are many, many ways that data can get hosed up, from datums and coordinates and projections. CDOT in this atmosphere, we know that everybody's using the exact same datum, coordinate, and projection. So number one, that is huge. Number two, everything is in a sub-inch environment. So this is just, getting this data. So this is what's going on the I-70 CDOT project. This actually is a couple of months old. This was back in January, and there are over 28,000 test holes that on that I-70 project today. The gray lines and points are abandoned or utilities that have been removed. The red dots are all of the new 3D data that is being brought in. And as of last month, very, very conservatively, CDOT says that well over 200 utility strikes have been mitigated on this project alone, just because the new data that's going in and all of the abandoned lines so the goal in a SUE environment is, how do we eliminate line strikes, just for the cost and the time and everything else. And this is one project. If anybody's seen the I-70 project, it is nuts. I mean, it is absolutely crazy. There is so much going on all the time. And the fact that we're able to actually mitigate line strikes is just, that's the reason. That's why we're doing these things. So this is a real quick demo on what the software actually looks like. So this is the main screen, and we'll have a background map. We can go into the settings, and here we identify the GPS device. This is a Trimble R2. We identify the locator, if it's RD or Metrotech. And now that we're capturing the data, we go into our real-time correction source. So this would be Trimble RTX. We'll be able to see that everything that is collected in those points are available to any of the users. All of this data that we're scrolling through is CDOT being very transparent in having background data and layers that are available to any contractor. We can change from a road map to a satellite view. So again, depending on what makes the best sense for the data collector. And for the field tech, the workflow is you just go to the new button in the top right-hand corner, and we'll be collecting the data. So you can see the GPS accuracy there was at 0.5, so 500ths. We're going into the TMOS codes here. This is a geology test hole. Otherwise, just as an observation, these are the fields that CDOT requires. So again, these are on the permits. All of this information is completed by the field tech. And as soon as we hit save, that accuracy is going to be captured at 500ths. And that is now residing at CDOT in their QA/QC. Now, if I want to send this back to our office for our records, you hit send, and this is all of the information that was collected. We can do it as a PDF. If there's attached photos, we can do KMZs, KMLs. And this goes out and just as a Gmail, it's an email, but we're able to also have that same data that we sent to back to CDOT. So we've captured this if it's going to go into plan and profile or any of that information. Really and truly, I can get people up and running in a CDOT environment, usually under an hour, because all of the heavy lifting has done in the back end. So all of these pieces fit. Like I said, I was part of the beta team for a year, and I really like what CDOT did. I think one thing that we kind of glossed over that I can't, stress enough on how important having a locator is, because what we traditionally do is have somebody go out and locate, and they mark paint on the ground, and then we may have a mapping person go back and map the paint. What the point man workflow does by marrying the locator and the GPS, when the locator actually hits the data set, we actually capture everything, the metadata from the locator. So we get depth of cover, frequency, signal strength, and we get that sub-inch GPS environment. So all of those pieces are captured. So we're actually getting that entire digital, line locate. We're getting the, the GPS accuracy. All of that is combined into that metadata. So looks like we got a couple of questions coming up. Let's question on whether these process and procedures are being implemented in Wyoming. The answer today is yes, we do have point man users in Wyoming, not necessarily in YDOT. CDOT was the first DOT to implement it in a statewide environment. The handwriting on the wall is very clear with CDOT. The mandate was put out for right-of-way because the right-of-way has very specific requirements, but I could certainly see this moving into all of their as-builds. There's just a lot of ways that this makes sense on getting continuity of data. So we're coming up on about 5 minutes left. Now we can go back into, I'm going to end this. So, questions and answers. Anybody, tell me something you took away, something that that you learned that you didn't know before. Pete, what'd you learn?
Well, I have that they're collecting a lot of data. And my question actually is going to be, is that data, these right-of-way easements, is that going to be made available to the public through their website, CDOT's website?
So right now, as a point man user, I don't want to go back into that PowerPoint, but all of that data, I had a phone call this morning from a brand new user that trained on Monday. They went out on Tuesday and called this morning because he was, it was a rental and he was bringing back the data and said, is there anything else I need to do? And because he's like, I checked the point man, all of my points are already in there. I collected about 60 points yesterday and they're in the CDOT platform. I said, that's the beauty. You're done. CDOT has that data. So as long as you're in the point man environment, the answer is absolutely. As far as the rest of the CDOT, I don't know, but that's, the point man and the right of way. The other thing that Rob's done that I think is just fantastic is how much transparency that he's bringing to this program. I mean, he really, really wants it to be successful. He's bringing the layers. He's doing everything he possibly can to make the contractor successful. So all of that data is available, and it's also for his inspectors. They're all seeing the same data. They're seeing the same accuracy. We have all of these same pieces.
So that is very, very impressive. And especially that amount of data. So, and again, Brian Robeson was asking if Wyoming's planning anything similar, and you kind of alluded to that.
There are a whole bunch of pilot programs going on in different DOTs, and I do know some, Wyoming people have looked at it. They've collected data. So the answer, Wyoming DOT specifically, I don't know. There are free trial programs, super easy to set it up, happy to, talk about how the workflow fits. I see something like this moving into a Colorado 811, in the future, just because, tickets and permits are sent electronically, they're updated electronically. We are having better accuracy. How far off in the future is that? Who knows? But, this is really, a very solid testing ground for, what CDOT has brought to the table.
And you're going to be doing more on this tomorrow or next week?
That is, tomorrow. That is correct. So we're going to go more in depth into the Pointman Pro environment. So that's the desktop, the back end. And I will, fair warning, those of that you join tomorrow, let's be lots more interactive. Let's, because this is your guys' time to ask questions and not for me just to, talk to an empty room. But, I'm really excited about the workflow. I'm excited about what CDOT did. It's pretty rare that I have 100% confidence in a workflow that I can get somebody set up and working in a sub-inch environment. But that back end was set up extremely well.
Well, again, you must have explained it way too well.
And you and I both know that's not usually the case when there's no questions, but okay.
Well, and I apologize, Dave. I was not aware of the schedule change, and I apologize for that. But I also want to thank Frontier Precision also for being a sponsor for the 2021 Elevations Geospatial Summer Series. We really appreciate it.
And just a GIS geek at heart, and we'll support anything GIS or field data collection related. So it's pretty exciting.
Well, and it's exciting for us too, and we certainly appreciate it.
Excellent. Well, we will stop so that you guys can get started on your next presentation.
Dave, thank you very much. Appreciate
thank
it
you.
again.
You
Thank
bet. Bet.
Actually, that brings us to an end for our morning session for today. Training programs are tomorrow. Please check the schedule again online, the program. And with that, I want to thank everybody for attending. And again, thank our sponsors, Nearmap, Woolpert, Frontier Precision, the University of Wyoming Geospatial Information Science Center, and Integrated Land Services. So see you all tomorrow. Thanks again, Dave. Thanks again to the presenters. And we'll all be in touch. Thank you.